Folks, I'm going to start. I'm super loud. That's how it starts, right? Folks, good morning. My name is Mauricio. I work for Adyen. I'm part of a new team there called the Tech Academy, where we try to improve the onboarding experience, trainings, and etc. for our 600, maybe 700 engineers right now. I am also affiliated with TU Delft. I'm part of the software engineering research group there. And most of my talk is all about the work we did, when I was a full-time assistant professor there. Yeah? Together with two companies in this presentation. One of them was indeed Adyen, the company I work for right now. The other one for ING. And well, the title says it all. Machine learning, can it really help software developers? We know it can drive cars, but can it really help what we do? And why should we be talking about this? A few months ago, I guess everybody heard about GitHub Copilot. So Copilot, you just write something in English. You know, I want to write this algorithm. You ask Copilot, and then Copilot writes some code for you. And I think this was the first time we actually saw some reasonably decent code being written by AI, right? And although you see lots of criticisms about this on Twitter, maybe that's what Twitter is for, but you have to agree with me, the technology is just super impressive, right? Maybe 5 years, 10 years from now, I don't even know what this is going to be doing. But this is just one example, maybe the fanciest one I have in my mind right now, but AI has been helping developers in other areas. And I'm going to just give you a bunch of examples, right? So besides GitHub Copilot, where else can we use AI? So if you think of the different tools we try to use to support software development, for example, SonarQube, because you want to see how your code is, how healthy your code is. Or maybe you want to find bugs automatically, maybe via spot bugs or something similar, or if you want to monitor, etc. Right? How do those tools work today? Think of SonarQube, for example. SonarQube gives you feedback if your class is too long. Behind the scenes, SonarQube just has an algorithm that was written by a human, and this algorithm just looks for patterns in the code, right? And this is super nice. This kind of works. The same for spot bugs, by the way. If you go to the source code of spot bugs, you just see that this is just a bunch of pattern matching that is kind of happening there. But the big challenge of this all is that those rules were implemented by humans, right? And in a way, those rules are just simplistic because we cannot see that far. So in the end, what happens is we all complain about lots of false positives from SonarQube or from PMD or from spot bugs. So this is maybe why, for example, AI can help, because AI can see further than you and create detection strategies that are better than what you can do as a person. So this is basically what I'm going to talk here today. And what I also want to emphasize is that most of us are not Microsoft, which means we don't have unlimited number of machine learning scientists to do really cool stuff. And we also have a limited computing power, right? I think just a few companies in the world can train a model as complex as GitHub Copilot. But simple models like the ones I'm going to show, any company can do this. So we did this at the university. I'm pretty sure you can also do this with your setup. And I'm going to talk about basically about two works we did. One was, can we train models to recommend refactorings? And the second one, can we recommend what methods to log, right? So let me start. These slides are a bit inherited from my lectures at Delft, so pardon if it looks a little bit like this. But there's a paper, if you want to read the details, let me just dive into it. So we all know what refactoring is about. We want to change the code a little bit so that it's just easier to be maintained. And we all love this, not because only Martin Fowler said this, but because lots of research actually shows that if you refactor, you get lots of benefits. This paper, for example, discussed refactoring at Microsoft. They studied teams doing some refactor at Windows and etc., and those are the things they observed, so we really like refactoring. But the challenge is, if you're in a super large software system, you probably have some legacy, you need to decide what to refactor, what not to refactor. This is a tricky question. You cannot refactor everything because you don't have money for this, but you don't want to also refactor nothing because otherwise life is going to be hard for you. How do you pick what to refactor? Again, you have tools like SonarQube and etc. And behind the scenes, how do they work? They mostly follow this paper over here. And the idea is you think of a bunch of rules. You think of a bunch of metrics that are cheap to be calculated, and you just implement those metrics. So if you look at God classes in PMD, how does PMD find God classes? It actually follows the precise formula from this paper, which is if complexity is higher than this, and if coupling is whatever, and then whatever this means. So if those three things are true, then this is a God class. I said this before, we think we can come up with pretty good heuristics, but maybe AI can do this better. So let's do this. How can we train a model that will recommend you refactorings? What we need to train a model first is data, right? We need to find data. And what type of data do I need to train a model that will start to predict refactorings? I need previous refactorings, yeah? So that's what we basically did. So we collected thousands of different methods that were refactored, and we just put them on a bucket, yeah? But if you want to do AI like what I'm trying to do here, you also need examples of things that were not refactored, so that the model learns to differentiate between these two, and that's what we want. So we collected thousands of methods that were refactored, thousands of methods that were not refactored, and we asked the model, learn from those, learn how to split. Yeah, that looks nice. What type of refactorings can you recommend? Well, basically all of them. And I just put a list here, you can read this later. But then the question is, how do you extract refactorings? How do you get this data, right? Because we are not usually very good at writing commit messages or labeling what we do. And you need thousands and thousands of data points. How can you do this? Luckily for us, some super smart people created this tool. This tool just gets your Git repo, it navigates the history, and it is able to detect all this type of refactorings. Yeah? So that's what you need if you want to do any machine learning model. You need to find a scalable way to collect data. So we basically executed this tool created by these folks in Canada in lots and lots of open source projects. So just an example here, we collected around 11,000 projects, most Java projects from Apache, F-Droid, and generic stuff on GitHub, basically 9 million commits. And those are the number of refactorings that we collected per time. So extract methods, we had 300,000 extract methods in the wild. And that's usually good enough data for you to start training models like this. So we had 300,000 extract methods. Let's just train the model. But you know, I said, let's extract the data, let's get refactorings. What does this precisely mean? What were we really extracting? In this one, we just thought of extracting simple things from source code, things you can extract super fast. For example, think of complexity metrics. It's very cheap to count the number of lines in a method, or complexity, coupling, cohesion, blah, 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 blah. You can go crazy like we did, and we collected like 40 metrics from the source code. What else can you get to make the model better, right? So, or to give more hints for the model to learn more. So we also collected what people call process metrics. That is basically metrics that are related to the history of a method or of a class. How many times was that method changed over time? How many lines of code it was added and removed over time, right? You can just get this information from Git. And ownership metrics are also usually quite popular in this type of work, so number of different people that have touched the class and blah, blah, blah. So we kind of combined these three groups of metrics, code metrics, process metrics, and ownership metrics. And we did this at 2 levels. So think with me. If you want to predict extract methods, you want to give to the model information about the method, right? How complex that method is. But this method is usually embedded in a class, right? And as a developer, when you're refactoring a method, you also look at the class to see what it looks like, to take this decision. Do I want to refactor or not? And that's what we also try to feed to the model as well. So we give to the model information about the method, plus information about the class, so that the model thinks like you, sort of. And that's what happens here. Not a lot of big secrets, so this is just a basic machine learning pipeline, so that we can be sure that our numbers make sense. So you collect lots of data. You want to do this in an automated fashion. You want to think of easy features to extract from the data so that you can do this in super large scale. Once you have all this data in, say, a CSV file or in a database, you just give it to scikit-learn, and you train a model. I'm being super shallow here. Of course, you want to do better machine learning than this, but that's kind of the gist of it. And in the end of the day, you can get just this beautiful table showing all the numbers, how good the model is, and blah, blah, blah. And this is just to scare you and kind of to show you that we did some cool stuff. But let me summarize some main results. So random forest, which is a super popular model outside the cool models in the industry right now, computer vision, NLP, and etc. Random forest is a super kind of simple and cheap model to train. And the random forests were able to predict refactorings with an accuracy of around 90%. So this means 9 out of 10 recommendations gave by this model, the model was correct, so it matched. When the model says refactor this method was actually refactored in real life. When the model says don't refactor this, the developer actually didn't refactor that method at any point. That's pretty cool, at least to me. We try different models because something you want to do as well is you want to go for the cheapest model. You don't want to just use a complex model because it's cool. You want the cheapest. And logistic regression is a super cheap one to be trained in a way. And so we sort of use it as a baseline. And even the baseline had an accuracy of 80%. So it's not that bad. And that kind of shows that deciding what to refactor or not is not really a complicated problem. Right? A model can model it. Cool, cool, cool. The model, or our results also show that code metrics are not only the most important thing there. The model also took information like the number of times a class or method was changed, the number of lines added in a commit, so how big your changes are over time, how many refactors you applied before, and blah, blah, blah. Those data points we gave to the model, they were very important in the end. The model was looking at this and let me use these to decide if you want to refactor or not. And finally, the idea of giving the context to the model. So you want to predict an extract method. The information of the class that this method is in was also very important for the model. So the context makes a lot of sense as well. Yeah? So this basically means we can kind of try to suggest refactorings. Cool, 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 so that works. What is next that we usually try to do? So once you have a model that seems to be working, you want to see how good it generalizes, right? I train a model here. Does this work for your company, for example? Yeah, the same way GitHub Copilot kind of generalizes. You can type whatever you want, and it generates code that makes sense to you. So what we did was, what happens if I train a model only using Apache projects? Will it be able to predict refactorings in F-Droid projects, which are mobile applications, right? And Apache is mostly libraries and frameworks. And so we did this, try all with all and blah, blah, blah. And you see that the results are not as good as what we did before, right? So the average accuracy dropped to 80% or something, so 10% worse, but still pretty good if you ask me, 80%. If you train on libraries and you test on mobile apps and you can still predict with certain accuracy, that's just impressive to me. So this tells me that, well, these models seem to generalize. Cool. So I implemented the first version of this. The good thing of working at TU Delft is that you find people that are smarter than you. A master student then got my project, made a lot of improvements, and you can actually use this if you want. You can just run the tool, collect the data, just train the data, and you have a model. Right? We even have this project over here that is a GitLab bot that you just plug on your GitLab and it can do the predictions for you. We also tried this in a company. So before, everything I was talking, it was mostly me and my colleagues in our rooms without windows. Then we went outside and let's try this somewhere, and we tried this at ING. This was the master thesis of David last year. And by the way, tomorrow he's going to know if he's the best thesis in the Netherlands of last year. He was already selected on the top 3, and he will know if he's a top 1 tomorrow. So cross your fingers. Huh? So what did he do? The first thing that he did was, okay, we have this model that we trained on open source projects. Will it apply on my industry crazy way of coding? Yeah? How can you, before just trying things out, how can you know? You should look at the distribution of the metrics. Yeah? So what do those models are learning behind the scenes? How those metrics vary? Yeah? So coupling, for example, think of coupling in Apache projects. Is coupling there similar to the coupling in your project? Is complexity similar to the complexity in your project? So he just did some data analysis there. What he noticed is that at method level, ING methods, or at least for the projects we studied here, they were not so different from open source. But in terms of classes, the classes were different. I don't remember how different we have to interpret this figure. Again, this is here just to scare you a little bit, but that's kind of the main message. Yeah, so the methods were kind of similar, but not perfectly similar. So we decided let's train a model that is specific for ING. So we did that, and we got also some fancy numbers. You can see there, accuracy of random forest. Random forest was, again, the best one, 90% or something. And at ING, our models were able to predict struct method at 90%, as I said. If we get the open source model and we try it at ING, the precision drops. So you can see 76% or so. So 15% less. So ING maybe deserves its own machine learning model to predict those things. Something that we also noticed is that even if you train on ING, some projects are so different from others that if you try on one project and you predict on the other, the accuracy goes down. And then this project needs a model for itself. And I think it makes a lot of sense, right? Because as a company, projects are so different from each other. Maybe one model for the entire company is also maybe it's not the best. But this tells me that those things actually may also work for the type of code you write in the industry. And then finally, we were just curious to see if developers at ING would also like the suggestions of the model. So what we did was we got 30 merge requests at ING, and we saw that the methods that developers submitted there, and we made the recommendation. You should refactor or not? And then we got those 30 methods we showed to developers. They didn't know the recommendation of the method, and we asked the person, would you refactor this or not? And then we matched with the answer of the model. And those are the numbers you see kind of over here. And if you see developer number 5, his way of thinking was 90% similar to the model. So this guy was basically the model. What we noticed as well is, for example, developer number 5 was the closest person among those people from the project. So this person was a developer. This person here was, I don't know, a team lead or something. So the person closer to the source code had was more similar to the model. We later discussed why disagreements happen. One case that I remember was that the method was not the best method you could write, but someone just said, you know, this is a pattern of our team. This is how we write stuff. We're not going to change this now. So they knew that the method was not good enough, but it was kind of, they were used to it. It was sort of a pattern for them. These things can also happen. Does that make sense? Good. Yeah. Is this still in use at ING? I'm going to talk more about it later. But maybe one more talk. And now, can we recommend log lines? This work was done by Jean. Jean is over there. Super nice to see. Yeah. Hey. Yeah, good. So the idea was very similar, but instead of trying to recommend refactorings, the idea was, can we recommend methods where we want to log? And this work was done at Adyen, so Adyen was kind of the case study. What do we mean by log? So what happens is we are coding stuff. Sometimes we want to just log to see what's going on, and we add stuff like this, right? Log4j lines. Well, this line is sent to some place, then this goes to monitoring and blah, 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 right? So this is sort of the whole process of what you do with a log line, and we were interested in here. Yeah? Why is that? Because as a developer, this is a very hard decision to make. Do I want to log this method or not? If you log too much, maybe you're going to just put a lot of useless data in your monitoring pipeline. Maybe you have to increase your capacity just because you're logging useless stuff. This might reduce also your ability to find anomalies and blah, blah, blah. But if you log too little, this means if a bug happens in production, then you don't have information to debug. Yeah, and then you have to hot patch and then wait for the bug again and blah, blah, blah. And think from yourself, how do you decide if a method deserves a log line or not, right? I'm pretty sure you have some some crazy heuristic in your mind, but it's not that explicit, right? You use your experience a lot. So the question is, can we also train a model that will help you in taking this decision? That was kind of the goal of this work. How does this work? Again, thing number one, you need to train these sort of models, you need data. Yeah? So the data for us was a source code from Adyen. So this is not an Adyen method, this is just an illustration. But the idea is we collected thousands and thousands of methods of the Adyen code base. And the first thing we looked at is, does this method have a log line? Remember, in my first picture, we want methods that have logs, methods that don't have logs, so that we can train a model that learns how to split between both classes, right? So our application, our program would look at a method like this and would say, yes, yeah, there is a log here. Yeah, and would put this method on the bucket of methods that have logs. And then we would calculate the metrics very similar to the ones I showed in the refactoring project, but we took one step before doing this, some pre-processing stuff, and this is also very common in machine learning, right? You want to massage your data a little bit, maybe to remove some noise and etc. And in here, what is the noise? Well, the noise is that in real life, what's going to happen is a developer will submit this in the pull request, and you want to predict in here, right? There are no log lines here, and if you learn from a method that has log lines, maybe the prediction will be not as good. So what we tried to do, we artificially removed the log lines of the method before getting the data, so that all the methods look the same when we are teaching the model. All of them don't have log lines, and the model has to learn from the characteristics of the method. And this is pretty tricky to be done in practice because you end up in so many corner cases. For example, one corner case is this. Imagine you have an if statement just for the log line. Yeah? That happens a lot, right? If, and then you log. But if you remove this log line, the if makes no sense anymore. What do? Do you just put open, close brackets here? Do you remove the if statement because maybe that's what the developer would do in the original method without log? So we decided we just remove everything. So you have to take all of those decisions. In the end, you have beautiful methods. You collect data, complexity, coupling, lines of code, blah, 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 blah. And in this work, something interesting was that we only used code metrics. So remember the table? We had code metrics, process metrics, and ownership metrics. As you can imagine, process metrics and etc., those are very expensive to be computed. You have to navigate the whole Git history, and that may cost you a lot, right? If you have a very large repo. In here, we said, let's just start with code metrics, right? Because they're super cheap to be calculated. You just look at the head of the repository, and there you go. So that's what we did here. Just to give you some intuition of how much data we had for this model, again, we collected around 300,000 methods at Adyen. Out of those, 23,000 had a log line. Yeah, so this gives you a 7.7% of methods with log lines. Do you think this is too much or too little? Have you thought about this? How many methods in your code base have log lines? Interestingly, this matches with research. There's a paper by Microsoft showing that some Microsoft projects have around 6% of methods being logged. Apache projects have something around 3%, if I remember correctly. So it's usually around 3% to 7%. So Adyen is not super out of the, not a big outlier there. But 7% is still a lot, huh? Right? Most methods have just one log line. You may have more. We didn't care about the number of log lines in a method. It's either true or false. You have logs or you don't have logs. We simplified the problem a little bit to explore. But this is what we then fed to the model. Yeah. And again, if you look at this crazy table, precision, random forest was again maybe the best one, 80%. Yeah. So this means that the model, whenever the model has to decide if there's a log or not, the model is 80% correct. Yeah? Which is amazing, right? 8 out of 10 methods that have logs at Adyen, a model could have predicted that. Just two of them, the model would have made a mistake. And something that we cared a lot when we were trying to train this model, or a trade-off we had in mind was, for us, it seems okay if the model misses some methods to be logged, as long as we don't bother the developers so much, right? Developers lose trust very easily. It's very easy for you to start trusting a tool. So we cared a lot about the number of false positives, you know, like the tool says, you have to log this method, and it's, that's not true. Google has a number internally, and I think it's something around 10% or 15%. That is, if your tool recommends something in my code and it makes more mistakes, it makes 10% is the maximum number of mistakes your tool can make. Otherwise, we're not going to deploy this at Google. Right? So developers are very picky about this. And so were we in terms of measuring stuff. And as you could see, the number of false positives was not super big, right? So 60,000 here you see, so 300,000 methods we had. We split a little bit so that we can train on some data and then test on another data, right? And we tested this model in 60,000 data points that the model never saw, of course, when learning from it. And only 600, 700 of them, out of 60,000, the model actually gave a false positive to the developers. Or in our controlled experiment here, right? So this seems okay. And then we were curious, right? The model is too good to be true. What does it learn from? What does the model really use behind the scenes to take the decision? And random forest is a sort of a complex decision tree, so you can kind of see the decision tree, right? And see which nodes the model think it's more important, yeah, because those are the nodes at the top that help you to take the first decisions. And we looked at it, and interestingly enough, the most popular code metric to predict logs were maximum number of nested blocks in your code. So think of ifs inside of ifs, inside of ifs, inside of fors, inside of ifs. This was just key for the model. Yeah, so that makes sense to me, right? If you have to do blocks inside blocks inside blocks, it is just because your method is super complex. Therefore, maybe you need to log it. So, and this number over here is just to kind of show that a lot of models, not only random forest, but other models kind of agree with this, that maximum number of nested blocks is super important for this. Yeah, maybe one more thing that we were curious, so we trained a model at Adyen. But what would happen if we train a model on open source? Will it work at Adyen? So what we did was we started to look at Apache projects. Why Apache? Because we trust Apache. They do complex stuff there. They also are very picky about what to log, because the whole world will see a log line if it is in an Apache library. So we manually picked 29 projects we trust. For example, CloudStack, one of them. And we trained the model there in the open source, and then we tried it at Adyen to see how it works. And the results are not very good. So the models in open source, as you can see here, so this is where we tested in the whole open source, precision is 60%. Well, it's not bad, but it's just a little bit better than a flip of a coin, right? Recall 25%, which means the model doesn't say we should log in cases where it should have said you should log many times. It misses 70% of these opportunities. So it is indeed a very low quality model when it comes to predicting, at least for Adyen. We tried for different projects to see if there was a project that would log similar to Adyen. CloudStack was the closest one, but you can still see, balanced accuracy was 70%. But, yeah, tricky, right? And to me, we started to try to reason about this, and I think that makes sense to me, because I feel like developers refactor usually for the same reasons, right? This method is too long, this method is too complex. But logging is super tricky. It really depends on the type of business you're building there, right? And what type of things you care about logging. Also, usually those frameworks over here, they mostly log, unexceptional cases and blah, blah, blah. But in industry systems, you may want to log some business stuff. If you should do this, that's another question, but that happens a lot in real life. So building a model that generalizes for this problem over here, suggesting what to log, we didn't get there. What did I learn from this? And these are two explorations. We have done more training models on trying to detect bugs, for example. Can you do this? We can talk more about it later, but what do I believe about this is I really believe machine learning will get to the developers very soon, very, very soon. For example, JetBrains works very hard on this. Even in Amsterdam, actually, the machine learning, part of the machine learning group is based on Amsterdam. So I'm pretty sure they're going to deploy something towards those lines very soon. Companies like Microsoft, GitHub Copilot is the popular one from Microsoft, but Microsoft has many of those small models internally, right? Microsoft just published a paper about a model that nudges developers when the merge request is late. So the model learns from, this is the merge request, this is the project. Usually people are 3 or 4 days late. If it's more than that, let's nudge the developer. So all those small models are being actually used by companies. Facebook has an entire group internally only for this type of models. This is going to get there, but there's lots of challenges. There's lots of things to be improved. We need to give it time for people to make this to work a little bit better still, but it will get there. And I feel like, why give this talk? Because I feel developers will trust more on those tools once you really know what's going on behind the scenes. You kind of understand PMD because we know how it works, but when a machine learning model is just giving recommendations, you don't trust it so much. And this was the issue with us at ING, for example. We deployed this as a GitLab bot in 5 or 6 projects there, and the model was giving the recommendations, and we were telling people, we tested this, the model looks pretty good, it matches with your human perception and blah, 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 but then the developers were like, nah, this is just a machine giving me a recommendation. And they mostly ignored the recommendations. Yeah, so I feel like there's also a lot of human-computer interaction involved in here, how we can really give this recommendation to developers. I remember talking to a person at Microsoft, and this person was telling me that they spent a lot of time fine-tuning the message in the merge request so that developers feel comfortable, that the machine is not, telling you you're not doing a good job and blah, blah, blah. So I feel this is super important. Where to give these recommendations? Yeah. Code review time seems to be a good one for me. I see a lot of people trying to discuss, can this be done inside of your IDE? That might be possible, although a little bit tricky, right? So even our models here, the refactoring model, the random forest, that model itself, that file was 1 gigabyte. Yeah? So imagine you having 20 of those models in your IntelliJ. You need 20 gigabytes of space in your disk just for models. That doesn't really scale, so this means maybe you have to send the recommendation to a server and get it back, but then do you want to really send your code over the internet? So there are lots of even questions like this, how to really feed this real life. Yeah? I like the topic, machine learning for software engineering. I don't do that so much anymore. That was kind of something I was doing at TU Delft, but there we have a super strong group doing this. If you want to try this in your company, talk to me. We can pretty sure find someone at Delft that can try these things out with you. Finally, some shameless self-promotion. I just published a book on software testing. It's called Effective Software Testing. It was published by Manning. And we have free copies in our booth. So go to the Adyen booth at 2:15, and you may get a copy over there. People are saying, it's not me, that it is a very good book, but I don't know. Yeah, folks, I'll leave it at that. Thank you so much.